So for our common ratio, we use a lot of different kind of like terms to describe the common ratio. But two that we're going to look at today is a growth rate, growth, or a decay rate. So growth or decay rate. And that just means the same exact thing as a common ratio. So can we talk about those two words? What do you think of when you hear the word growth? A positive, you think of a tree, a little kid. Why do you think of growth or why do you think of a little kid? And they're growing. What else do you think of when you think of growth? Think like math words as well. A graph. What did you say, Caitlin? Addition, that's good. What else? Multiplication. Exponents. I think of like increasing, right? Increasing things, right? And then what do you think of when you hear the word decay? Sad. Dead. A grave. Old. Mold. Did you say mold or old? Huh? Negative. What about the opposite of increasing? What about the opposite of addition? And the opposite, yeah, divide. Right? It's getting smaller, right? It's breaking down. Have you ever heard of this word before? What? Depreciate. Very good. What does it mean for something to depreciate? The value goes down. Can you think of an asset that depreciates over time? Yeah, so money is good because it does depreciate, like cash money depreciates over time because of inflation. So $20 now is not going to be the same as $20 in 20 years. Good. What'd you say, Isabel?
Like cars.
Yeah, so most cars that we drive depreciate over time. Can you think of a situation where a car would increase in value? Like an antique car or like a fancy sports car, right? If I had an old Mustang from the 60s, that would be worth a lot of money. Yeah, or if it's like a special, like limited edition car. What else depreciates in value over time? Actually, houses appreciate over time. Unless it was something like you totally let this house go to ruin and the roof was caving in and blah, blah, blah. But property in general increases in value over time. Sometimes it dips, but what do you mean? That are going extinct? Yeah, yeah. Like, yeah. Huh? People, yes, people depreciate, I guess, over time, right? Huh? Beauty, yeah. It's true, we're all going to be old and wrinkly one day.
Looking like this when I'm
What's your secret? Plastic surgery does not make you look younger. It just makes you look plastic. Okay, so we said a bunch of stuff. Cars. What about your phones or a computer? You can refurbish it, but can you sell it for more than you bought it for?
Well, think about like a phone that was like when phones first started if you had one of those and you sold it to like YouTube, they'd probably give you a lot.
No, but you also have Nokia thing.
Yeah, but there were, yeah, like maybe, but that will happen when there's like a limited amount of them left. You know what I mean? There's like millions of Nokias out there. I don't think you can get a whole lot of money for an old Nokia.
Like, what's the thing? Those things.
Yeah. Yeah, certain things like that, yes. But for the most part, right, you buy an iPhone for like $1,000 and then 2 years later a new iPhone comes out. Your old iPhone is obsolete now. You might get a couple $100 for it, maybe. Right. A sidekick? What? Sorry. A sidekick. They were the coolest thing in the world. You have one? Because you could. All right. So we're going to use that information to help us with this paper. So flip to this paper, please. And at the top of your paper, let's rewrite that exponential equation. Y equals A times B to the X. And what did we say A tells us? The starting amount. It's not the smarting amount. Starting amount. And what is B? Mm-hmm. And for this paper, our X is always going to be the amount of time, whatever the time is that we're looking at, okay? But our growth and decay rate look different depending on whether we have growth or we have decay. So that value of B is going to kind of look different depending. So for our growth rate, B equals 1 plus R. 1 plus R. And the decay rate will look like this. B equals 1 minus R. Okay. So let's do this first problem together and then I'll have you work on your own. So you're buying a house for $130,000 and it appreciates 6% per year. How much is it going to be worth in 10 years? So is this growth or is this decay? Growth. Okay, and what is the initial amount? 130,000. And so now I'm looking for my growth rate, right? My growth rate. So what percent is it growing by each year? 6%. But then it says I need to switch that into a decimal. Very good. 0.06. How did you figure that out? Very good, right? You take your percent, 6, and just divide it by 100. You can think about just moving the decimal point over 2 places as well. Either way. Okay, but we need to have the percent written down as a decimal. And then now we have enough information to write our equation. So I start y equals, and then A. What is A? 130,000, my starting amount. And then for B, so it's not just 0.06, it's going to be 1 plus 0.06. 1 plus 0.06. And then my exponent is the amount of time I'm looking at. How much time? 10 years. Okay? So I need you to come up with your, so now from here, you can find your answer by just plugging this right into your calculator, whatever it's called. And plug it in exactly as you see it. 130,000 parentheses 1 plus 0.06 parentheses raised to the 10th power. And I'm going to come around and check your answer on that one. Yeah, it'll be a decimal. And remember, it's money that we're talking about. So you don't need to write all of those numbers past the decimal, just 2.
Now start working on the next one. Okay. That's a relative question. Yeah. I don't know. What do you mean by really big?
Like that?
I'll come over there and.
Like 6 digits?
No.
Yeah, that's not, yeah. 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 Right. No. But you didn't do it right. You didn't do, you need to use a parentheses. Yeah. Go on. It's divided by 100. Can you have like 0.3 over here? Yeah. Take this and exactly it's just. I think it does it. Wait.
I think it is that. I think you're right. Yes, you're good.
You don't need to include it as. So it's saying how to be in the rate, so it's saying per year, scoring by baseline. So for 5 years, we have to apply that five. Okay, so that, I realized, it's like, I don't know, it was the only one that was using. Yeah. So it kind of. And they're trying to, just use all the different. How many?
Hold on. Not by phone?
Yeah, so it says each month, and then it says that it's
Oh, happy.
for half a year. So how many months is half a year?
Okay.
Oh.
Half of these are missing.
Huh?
Half of these are missing.
That's okay. You can still do it. You could just copy down what the other ones had. So how many years has it been since 2010? Yeah. Want to do the same thing? She said 14. Yeah. Be careful.
Making sure it works, try that picture. That's exactly what it's just one of the, it was after. So you did a, right? So that it did, I was going up. Wait, yeah. No, so you're starting to tell here those are questions, right? No, it's not, but it's to 14, right? So it's makes it clear. And then try 15. You just experiment with these. That's the most one. I'm sorry. Yes. How would you do that? Mark, can you have a gate, please come to the office? Mark, can you have a gate? I'm going to go to the bus. About oh, it's going. Wait, is that I thought you kept saying shooting. Shooting. It's so hard. Maybe, I don't know. Can any of you guys please put the whiteboard markers back over there before you leave?